In this video, we will explore the link between cloud computing, data centers, and data security in higher education. Let's begin with cloud computing. We've all heard of the cloud, but we can't see it. If you've ever accessed a file from a shared drive or backed up your phone's photos to Google Drive or iCloud, you've used it. But what exactly is cloud computing? Let's break it down. According to Techopedia, computing is the process of using computer technology to complete a given goal-oriented task, while Oxford Dictionary defines the cloud as a network of computing facilities that provide remote data storage and processing services via the internet. Combine the two, and we get cloud computing, the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. It's important to note that the cloud is more than just storage. The cloud is a dynamic ecosystem that is designed to empower individuals and organizations to innovate, collaborate, and scale efficiently. In the context of education, cloud computing enables faculty, staff, and students to store and access files from any device, anywhere, collaborate in real time with peers or colleagues, and back up files for seamless recovery in the event of hardware upgrade, failure, or loss. At the organizational level, the cloud enables universities to centralize and streamline administrative data, such as enrollment information, HR data, and financial records, conduct complex research tasks that require significant computational power, facilitate virtual learning environments that allow students to access assignments, submit their work, and engage in online discussions with peers, and safely and securely store private data, such as student information, research findings, and intellectual property. Now that we've explored cloud computing and its applications in higher education, let's dive deeper into the network of remote servers that power cloud computing. Data centers. Data centers are physical buildings that house computing machines and related hardware equipment for the purpose of storing companies' digital data. Let's explore what components make up data centers, their functions, and how they can be designed with energy consumption in mind. The primary components that make up a data center are compute and storage hardware, networking and power, and cooling infrastructure. Compute and storage hardware are the driving force behind applications and data accessibility, and these components are housed in a data center. Hardware examples include servers and server racks, processing and memory chips, and hard drives. Networking and power infrastructure enables the incoming and outgoing flow of data at high speeds, and examples include power supply, backup power, and Ethernet. Finally, the cooling infrastructure keeps the equipment at a safe temperature to prevent data loss or failure. Components of the cooling infrastructure include chillers, raised access flooring, and the concept of hot and cold aisles, which we'll discuss later. Next, let's dive deeper into what goes into a server rack. Server racks house a variety of data storage and processing components and accessories. They are completely customizable depending on the use case and end user's needs. Stacking servers and other IT equipment within a server rack optimizes organization and airflow. The key components of a server rack can be visualized using this planning template from Lucidchart. We'll start with networking equipment. Networking equipment, such as routers, switches, and firewalls, maintain reliable connectivity and security with the server infrastructure. Storage equipment and servers are high-functioning, powered machines that pull and push data between themselves and the client. While network-attached storage is a centralized file server that allows multiple users to store and share files over a Wi-Fi network or Ethernet cable. Finally, UPS stands for uninterruptible power supply and provides uninterrupted power to the server rack in the event of a change in power, preventing downtime and data loss. When you look at photos of data centers, you'll notice a plethora of different colored cables. To the untrained eye, the abundance of cables may seem chaotic and overwhelming. However, the cable colors denote a specific cable's function. The Administration Standard for Telecommunications Infrastructure of Commercial Buildings has recommended a standard color code to identify and label colors based on their function. You can see some of these colors in the photo on the right, such as blue, orange, green, and yellow. This distinguishing visual characteristic serves the purpose of connecting everything within a data center, including server components, monitoring and communications, security, network, access, and more. Next, let's talk about energy consumption. It's evident by this point that data centers require heavy computing and storage capabilities to manage its organization's data, which can be a drain on energy consumption. In fact, according to the US Department of Energy, data centers are one of the most energy intensive building types, consuming 10 to 50 times more energy than commercial office buildings of similar size. This is attributed to the significant energy consumption required by servers, networking devices, storage drives, and cooling systems. Data centers are responsible for 2% of the electricity consumed in the United States. There are measures that can be taken to decrease energy usage in data centers, such as purchasing energy efficient equipment and decreasing light usage when the data center is not used by personnel. One energy saving method I learned about during my research is called the hot aisle cold aisle configuration, which reduces operating costs by effectively managing warm and cool airflow. Let's look at an aerial view of equipment racks on the floor of a data center. Equipment racks have a cool side, where cool air is supplied to the equipment, and a warm side, where hot air is emitted from the equipment. When the two aisles face each other, the warm air is pumped towards the intake area that requires cool air, putting the equipment at risk for overheating and requiring heavier cooling methods from the building's HVAC system, thus using more energy. However, by orienting the equipment racks with the warm exhaust air facing one another, the cool air intake aisles are no longer polluted with warm air by design. The warm air is contained to its own aisle, as is the cool air. With this configuration, chillers can be placed over the warm aisles to capture warm air and reuse it for other facility functions, and the hot aisle, cold aisle configuration saves energy by optimizing the placement of warm and cool air. Data centers offer a host of benefits at the university level. By tapping into data centers, universities can realize space savings, cost savings, and energy savings. For example, outsourcing data processing and storage to data centers frees up on campus facility requirements, requiring less maintenance and financial responsibilities. In addition, by harnessing the computing and storage power of off-site data centers, universities can save energy costs and benefit from consolidating their operations within a shared data center. Finally, as universities increase their utilization and reliance on data centers, data security must be addressed. According to Pluralsight, the data stored by higher education institutions makes them prime targets for cyber attacks. Universities handle sensitive information such as financial records, personal identifiable information such as social security numbers, intellectual property, and research. In the higher education sector, end users, such as faculty, staff, and students, universities, and data centers share the responsibility for keeping data secure. Let's explore the responsibilities at each level, beginning with the end user in this context, faculty, staff, and students. Faculty, staff, and students are responsible for using strong passwords, changing them regularly, and keeping them safe. They're also responsible for avoiding phishing, malware, and social engineering attempts, and proper data handling, which includes securing and encrypting sensitive data and disposing of it properly. Data centers are responsible for maintaining digital security, which includes monitoring network traffic for anomalies and ensuring software is up to date to patch vulnerabilities. Physical security of the data centers should also be addressed, ensuring that no unauthorized visitors are to gain access to the premises and ensuring that only authorized employees are allowed within certain areas of the facility. They're also responsible for maintaining compliance with industry standards and regulations. Finally, universities are responsible for creating clear data security policies and guidelines and enforcing them, as well as conducting routine risk assessments to identify weak points in their security measures and addressing the risks. Universities are also responsible for educating faculty, staff, and students on the importance of data security and providing practical strategies for keeping information safe. Universities should also partner with data centers to conduct risk assessments and share results, ensuring that vulnerabilities can be addressed from both sides. They should also collaborate on incident response plans to ensure that there's a backup strategy in the event of an outage or security breach. Another layer of shared responsibility lies between end users and data centers, as end users are accessing data stored within data centers, while data centers are responsible for securely disposing of data when it's no longer needed. In a data-driven society, cloud computing, data centers, and data security play a vital role in enhancing the education experience. Universities, end users, and data centers must continue to collaborate to foster innovation in education while processing and protecting data.